What if the way you measure your life, every second, every minute, every hour, was shaped not by modern science, but by a civilization that existed over 5,000 years ago, long before the ticking of clocks or the hum of satellites, before calendars, compasses, or even written history? There were people who looked to the stars and found meaning in their patterns. These were the Sumerians, the world's first known civilization. From the heart of ancient Mesopotamia, they did something extraordinary. They divided time into pieces. They tracked the heavens with naked eyes. They carved mathematics into clay tablets. And in doing so, they created the foundations of how we understand time itself. Your 60-minute hour, your 360-degree circle, your calendar of months and years, all of it began here. This isn't just the story of how time was kept, it's the story of how time was invented. Welcome to Ancient Knowledge Explained, a channel dedicated to uncovering how the world's earliest civilizations understood science, math, and philosophy long before the modern age. We're not just talking about kings and pyramids, we're exploring the minds of the ancients, how they built cities aligned with the stars, measured time with the moon, and used geometry to connect the heavens with the earth. In each episode, we'll dive into the scientific brilliance hidden within the temples of Egypt, the logic of Greek philosophers, the astronomical records of Babylon, and the lost knowledge preserved in ancient India, China, and beyond. No myths, no fluff, just deep cinematic journeys into the logic, structure, and wisdom of the past, designed to fascinate your mind and open new perspectives. So if you're someone who believes the ancients knew more than we give them credit for, you're in the right place. In today's episode, we begin at the very origin of measured time, with the people who turned the sky into a calendar and laid the mathematical foundation for civilization itself. Let's begin. To understand the invention of time, we must begin where civilization itself began, Sumer. Roughly 5,500 years ago, in the fertile lands between the Tigris and Euphrates rivers, something remarkable happened. A scattered network of farming villages slowly transformed into the world's first cities, Uruk, Eridu, Ur, and Lagash. This region, known as Mesopotamia, meaning the land between rivers, wasn't just fertile in soil, it was fertile in ideas. As populations grew, so did complexity. People needed systems to manage food, labor, water, trade, and belief. They needed structure, not only in architecture but in thought, and structure requires measurement. The Sumerians began organizing their world through written records, using one of humanity's earliest scripts, cuneiform, wedge-shaped symbols pressed into clay. They documented everything: grain supplies, temple offerings, legal disputes, and astronomical observations. But to make sense of recurring patterns, flood cycles, planting seasons, religious festivals, they had to think bigger. They had to understand time. And so they looked up to the sky, where order never failed. The moon waxed and waned in perfect rhythm. The stars appeared and disappeared with the seasons. The sun rose and set without fail. The Sumerians began to realize something profound. Time was not chaos. It was cyclical, predictable, and possibly even divine. And in a world without clocks, the night sky became their greatest tool. Priests, often acting as astronomers, climbed the steps of temple ziggurats to observe the heavens. They weren't just looking for beauty, they were watching for signs. When should crops be sown? When should festivals begin? When would the gods send blessings or warnings? In Sumer, timekeeping wasn't just practical, it was sacred. It was about aligning human activity with cosmic rhythm. It was about syncing earthly order with divine will. This early connection between sky, math, and meaning would define not only Sumerian civilization, but the entire future of science. To understand how the Sumerians measured time, we have to talk about numbers. Not just any numbers, but a number system unlike the one you and I use today. Base 60, also known as the sexagesimal system. If that sounds strange, it should. We're used to base 10, or the decimal system, counting in groups of 10 fingers, 10 toes, 1, 2, 3, 10, then 11, simple, logical, familiar. But the Sumerians didn't count like that. Instead, they used a hybrid system combining base 10 and base 6 to create something more flexible, more elegant, and in many ways more powerful. So why base 60? Because 60 is incredibly divisible. It can be evenly split by 2, 3, 4, 5, and 6, and even 10, 12, 15, 20, and 30. That made it the perfect number for trading, measuring, calculating, and organizing complex tasks. Imagine dividing an hour into even parts. Try with 100 minutes, you'll struggle. Now try it with 60. Suddenly, everything breaks cleanly. You can divide 60 into halves, thirds, quarters, fifths. No messy fractions. And this wasn't just theoretical. It was practical, essential in their daily lives. Dividing rations, measuring fields, calculating lunar cycles, organizing temple rituals, all benefited from the modular beauty of 60. And here's the amazing part. We still use it today. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. That last one, the circle, is no accident. The Sumerians believed in cosmic harmony. A full year was approximately 360 days in their reckoning. So they applied that number to the heavens, dividing the circle into 360 equal parts. This wasn't just numerology, it was observational science fused with spirituality. By mapping circular motion of the sun across the sky or stars around the pole, they used geometry to represent eternal cycles. They didn't use calculators, they didn't have decimals. Instead, they worked with fractions, meticulously catalogued on clay tablets. They even had tables of reciprocals, used like we use multiplication charts today. For example, need to divide a field into thirds. They could quickly retrieve the reciprocal of 3 in base 60, 20. 60 divided by 3 equals 20. It was fast, efficient, and scalable, the ancient version of a calculator. Even for advanced astronomy, this system served them well. When tracking planets, predicting eclipses, or creating star catalogues, they leaned on sexagesimal calculations to achieve accuracy that would impress even Renaissance scientists. Think about it. A system invented 5,000 years ago by a civilization without metal tools or compasses, or even the concept of zero. And yet, that system is still ticking away in your phone's clock, in your GPS coordinates, in the angles of every shape you learned in school. The sexagesimal system wasn't just about numbers. It was about making sense of a complicated world. It was a tool that brought order to chaos, structure to time, and precision to the cosmos. And it all started with the Sumerians. The Sumerians didn't have telescopes, they had no satellites, no observatories, at least not as we know them. And yet they watched the heavens with such patience and precision. Their observations would echo for millennia. To them, the night sky wasn't just a backdrop. It was a living calendar, a divine text, a map of time itself. It began with the moon, the most obvious and reliable pattern in the sky. They noticed how it waxed and waned, always returning to the same shape every 29 to 30 days. From this, they created one of humanity's earliest known lunar calendars. Each month began with the first visible crescent moon, a practice still seen in some modern calendars today, including the Islamic calendar. A year was made up of 12 lunar months, totaling about 354 days. But here's the problem. A solar year, the time it takes Earth to orbit the Sun, is around 365 days. That left an 11-day gap. Over time, this mismatch would cause seasons to drift. So the Sumerians introduced a correction. Every few years, they added an extra month, a process called intercalation. This kept the calendar aligned with the seasons and the cycles of agriculture. They weren't just counting days, they were engineering harmony between heaven and earth. In ancient Sumer, priests weren't just religious figures, they were scholars, mathematicians, and most importantly, sky watchers. Atop temple ziggurats, they spent night after night observing the stars. They noticed that certain stars rose and set at predictable times of the year. They began tracking heliacal risings, the first appearance of a star before dawn, to mark important transitions, such as the beginning of harvest season or the approach of floods. They also identified constellations, including early versions of what we now call Taurus, Scorpius, and Orion. These weren't just pretty patterns, they were seasonal markers, mythic symbols, and tools of measurement. Some of their records even mention the Pleiades, a tight star cluster still used by farmers in many cultures to this day. Their understanding wasn't limited to stars, it extended to the wandering lights, the planets. They noticed that unlike fixed stars, certain lights moved through the sky along a regular path, what we now call the ecliptic. They called these the wandering stars and tracked their motion with care and awe. Among the most mysterious phenomena in the sky were eclipses. When the moon went dark or the sun vanished in daylight, it was no ordinary event. It was a message from the gods. Sumerian priests recorded lunar and solar eclipses meticulously. These weren't merely scientific records, they were also used for divination. In particular, they believed lunar eclipses could signal danger to the king or the kingdom. Special rituals were performed, and sometimes substitute kings were temporarily placed on the throne, just in case fate struck down the wrong man. But behind the superstition was science. The more eclipses they recorded, the better they became at predicting them. They noticed the moon followed cycles, patterns of repetition known today as the Saros cycle. This blend of religion and empirical observation is what made their work so enduring. They didn't have a modern scientific method, but they valued patterns, precision, and persistence. Some of the oldest astronomical texts in the world, like the Enuma Anu Enlil, come from Sumer and Babylon. This monumental series of tablets included 7,000 omens based on celestial events. From the color of the moon to the brightness of Venus, every variation had meaning. Their goal wasn't just to look at the sky, it was to decode it, and their dedication paid off. By 1800 BCE, Babylonian astronomers were predicting planetary movements and recording star catalogues that would later influence the Greeks, Persians, and Islamic scientists. In fact, the Babylonian star catalogue known as Mulapin, compiled later from Sumerian roots, was used for centuries as a practical guide to the heavens. It's easy to take the sky for granted today, but imagine looking up and seeing your calendar, your ruler, your clock, and your gods, all shining down on you. For the Sumerians, watching the sky wasn't a hobby, it was a sacred duty, a daily act of science, and a pathway to understanding the nature of time itself. They didn't just observe the stars, they organized their civilization around them. And in doing so, they gave us one of the most powerful ideas in human history, that the universe has structure and time can be known. As the Sumerian cities declined, their intellectual flame did not die. Instead, it was passed on to a new power rising from the same fertile land. That power was Babylon. By around 1800 BCE, Babylon had become the heart of Mesopotamian science, culture, and innovation. And while the Babylonians inherited much from the Sumerians, their writing, their gods, their architecture, it was in astronomy and mathematics where they truly took the torch and ran. Like the Sumerians, the Babylonians were obsessed with the stars. But where the Sumerians had laid the groundwork, the Babylonians began to build a system. They compiled centuries of observations onto clay tablets, recording the positions of stars and planets, eclipses, and unusual sky events. And most impressively, they didn't just watch the sky, they began to predict it. One of their greatest achievements was the Mulapin, a star catalogue dating back to at least 1000 BCE, but based on much older Sumerian sources. This wasn't just a list of stars, it was a manual for the cosmos. It detailed the rising and setting times of key constellations, the length of days and nights through the year, the movements of the moon and planets, seasonal markers for agriculture and ritual. Think of it as a hybrid of astronomy textbook, farmer's almanac, and spiritual guide. It shows a sky divided into 3 celestial paths, one for each of the chief gods, Anu, Enlil, and Ea. Even their heavens were organized by theology and observation working hand in hand. Another triumph, the Venus tablets of Amisaduqa. These tablets track the rising and setting of Venus over a 21-year period. They note the planet's visibility in the morning and evening sky, its disappearance and return. Why Venus? Because it was associated with the goddess Inanna or Ishtar, the deity of love, war, and fate. To the Babylonians, Venus wasn't just a planet, it was a divine messenger. Its cycles foretold prosperity or disaster. But behind the religious symbolism was something profound, empirical science. By tracking Venus over decades, the Babylonians laid the foundation for understanding planetary motion, centuries before Copernicus or Galileo. The Babylonians also became masters at predicting eclipses. Through detailed sky records, they uncovered repeating eclipse cycles, especially the Saros cycle, roughly 18 years in length. This cycle allowed them to forecast when the sun or moon would darken, a feat unmatched in the ancient world. Their work with planets was equally advanced. They plotted the movement of Jupiter, Saturn, and Mars, calculating their paths with surprising accuracy. Some tablets even hint at early mathematical models of motion, primitive precursors to what we now call epicycles in Greek astronomy. At the center of this astronomical revolution were Babylonian priests, often working in temple complexes like those of Esagila in Babylon. These were not simply mystics interpreting omens, they were careful record keepers, meticulous observers, and developers of the world's first predictive astronomical models. In many ways, they were proto-scientists, using repeated measurement, long-term data, and mathematical structure to explain the heavens. What began in Sumer found new form in Babylon, more refined, more systematic, more predictive. Their legacy didn't end there. Babylonian astronomical knowledge would later be adopted by the Greeks, Persians, and Islamic scholars, forming the very backbone of medieval and Renaissance astronomy. The Babylonians didn't just inherit the torch, they made it brighter and passed it on to the world. The Sumerians and Babylonians didn't just observe the sky, they began to measure it. And from that act of measurement came geometry. Let's start with the circle. To the Babylonians, the circle wasn't just a shape, it was a symbol of perfection. It echoed the endless cycles of the sky, the orbit of the moon, the return of the seasons, the constant loop of the stars. They divided the circle into 360 degrees, a number that wasn't chosen randomly. Why 360? Because it mirrored the solar year, roughly 360 days by their reckoning. It also worked beautifully within their base 60 system. 360 divides cleanly into halves, quarters, sixths, tenths, creating a system that was elegant, consistent, and easy to work with in both astronomy and everyday life. Every time you measure an angle, draw a triangle, or turn a compass, you're using Babylonian geometry. But Babylonian geometry wasn't just practical, it was spiritual. Their temples, especially the great ziggurats, were built using sacred ratios, aligned with cardinal directions, measured according to astronomical events. Many were constructed to mark solstices, equinoxes, or the rising of particular stars. Geometry was used to bridge heaven and earth, a tool not only for construction, but for connection. For example, the famed Eta Menanke ziggurat, believed to have inspired the Tower of Babel myth, was not only a monumental structure, it was also cosmologically symbolic. Each level of the ziggurat represented a layer of the universe, from the underworld to the stars. Geometry gave form to myth and meaning. Babylonian mathematicians developed methods for calculating area, volume, and angles. They understood the Pythagorean theorem centuries before Pythagoras. They worked with triangles, quadrilaterals, and circular arcs. On one famous tablet, now called Plimpton 322, they listed sets of numbers that describe right triangles. Historians believe this could represent a kind of proto-trigonometry. But here's what's remarkable. They achieved this without algebra, without zero, and without symbols as we know them. They used logic, tables, and clay tablets marked with reeds. Their math wasn't abstract, it was tied directly to the rhythms of the world. Babylonian geometry would influence Greek mathematicians like Thales, Euclid, and Ptolemy, and later, Islamic scholars would build upon their models to refine astronomy and algebra. What began as a way to measure fields and temples became a framework for understanding the cosmos, and it all started with circles drawn in clay by people who believed numbers revealed the mind of the gods. To the Sumerians and Babylonians, time was not just a tool. It wasn't just something you tracked or measured or calculated. Time was sacred. It was the rhythm of the cosmos, the heartbeat of the gods, a force that brought order to chaos and meaning to existence. They believed the sky wasn't random. It was intentional. The rising of the sun, the phases of the moon, the shifting of the constellations through the seasons. These patterns weren't merely natural. They were messages from the divine. By observing these cycles, they believed they could align their lives with a universal order, what they sometimes called the cosmic laws set by the gods. When a priest looked to the sky, he wasn't just searching for data. He was seeking balance, guidance, and permission. Timekeeping became a form of authority. The priests, as keepers of calendars and omens, held the keys to divine timing. They determined when to plant, when to sacrifice, when to crown a king, or when to declare war. Rulers themselves were believed to govern by divine appointment, and their legitimacy depended on their alignment with celestial timing. If an eclipse occurred on the wrong day, that wasn't an astronomical event, it was a cosmic warning. In some cases, a substitute king would be placed on the throne for a few days to absorb the bad omen, and then quietly removed. The real king returned once the danger passed. This wasn't science versus religion, it was science as religion. The structure of time as mapped by the heavens was a spiritual code, one that linked society to the divine. Every moment mattered. New moons meant new months. The equinox meant balance between light and dark. Festivals followed lunar and solar rhythms. Ceremonies were carefully timed to match celestial movements. Their lives were lived in sync with the stars. Even death had its timing, with burials and mourning aligned to moon phases and planetary positions. Time wasn't just about when things happened, it was about how to live properly within it. In the modern world, we see time as mechanical, digital, linear. But to the ancients, time was alive. It moved in cycles, not straight lines. It was a divine rhythm, not a countdown. And by observing, honoring, and aligning with that rhythm, the Sumerians and Babylonians believed they could maintain harmony with nature, with society, and with the gods themselves. Time was not just a measurement, it was a sacred order. Thousands of years have passed. Empires have risen and fallen, languages, beliefs, and borders have changed, but their system of time never stopped ticking. Every time you glance at a clock, schedule a meeting, or track a year, you are participating in a tradition that began with the Sumerians. The 60-minute hour, the 360-degree circle, the calendar month, these are not just modern conveniences, they are ancient legacies. They were born from observation, refined by belief, and preserved through ritual and record. The Babylonians took those early insights and turned them into a working model of the cosmos, one detailed enough to predict eclipses, track planets, and structure civilizations. And remarkably, their knowledge didn't end with them. Greek astronomers like Ptolemy studied Babylonian records. Islamic scholars translated and preserved their texts. Even modern astronomy owes a debt to their sky-watching traditions. What began on clay tablets now lives in satellites, atomic clocks, and space probes. But perhaps the greatest legacy of all is not in the numbers or the math. It's in the idea that the universe is knowable, that by watching carefully, thinking deeply, and recording what we see, we can bring order to chaos and understanding to mystery. The Sumerians and Babylonians didn't just invent timekeeping, they invented a mindset, a way of thinking that still defines science, philosophy, and human progress. They were the first timekeepers. And we are still following the clock they set in motion. If this journey through ancient timekeeping has opened your eyes to the brilliance of early civilizations, Don't let the learning stop here. Subscribe to Ancient Knowledge Explained, where we uncover how the earliest minds unlocked the secrets of science, math, and philosophy. Drop a comment below. Which ancient invention surprised you the most? Was it the base 60 system, the Venus cycle, the sacred geometry? And if you found value in today's episode, please give it a like. It helps more curious minds find this channel, and it tells us you want more. Coming up next, how the Egyptians used geometry to build eternity. A deep dive into how sacred numbers, pyramids, and cosmic alignment shaped one of the most iconic civilizations in history. Until then, keep asking questions, stay curious, and remember, the past still lives in the way we measure every second.